All right, here's my second example, okay, and about testing claims, hypothesis testing. Remember, we're following 7 steps, and I'm going to show you how you follow these steps. So first thing, let's read the word problem. A local telephone company claims that the average length of a phone call is 8 minutes. In a random sample of 18 phone calls, the sample mean was 7.8 minutes and the standard deviation was 0.5 minutes. Is there enough evidence to support this claim at alpha level significance equal 0.05? So let's follow the steps. Step number 1, let's write the claim mathematically. Remember that I gave you the suggestion to underline the claim in the word problem. And you can see it's going to be located in the first sentence. A local telephone company claims, here comes the claim, that the average, which is the mean, mu, the average length of a phone call is 8 minutes. So step 1, what I underline, I'm going to write it mathematically. So mu equal 8. Because the word is means equal, and this is my original claim. This is the claim that came from the word problem. Now don't forget, every claim has a counterclaim. So how do we find the counterclaim? State the opposite of what the original claim says. So the opposite of being equal is not equal. So mu not equal to 8. Now that I have the original claim and the counterclaim, we need to label it as HO and H1. Whatever claim has the equal is HO. Whatever claim doesn't have the equal is H1 or HA. And I did step number 1. Here we go with step number 2. Follow the steps. That's all what you had to do. Specify the level of significance. My level significance is 0.05. That's my alpha. That's what level significance. Oh, that's the label for the level significance. In step 2, I just need to find out how much is alpha. And I did it. Here we go, step 3. Step 3 is when we do the picture. Okay, and the picture is a bell-shaped curve. So I'm going to draw the bell-shaped curve. Here it is. And I need to decide which tail I'm going to shade. Who decide the tail, which tail you're going to shade? H1 or HA. And because I have a not equal, it means I'm shading the two tails. That's what I'm doing. See, I'm shading two tails in this graph. And that's it. That's step number 3. Step number 4, okay, we're following the 7-step process. We're going to calculate the test statistic. Don't forget that the test statistic is a number that we're going to find using a formula. Which formula? One of these 3. How do I know which of these 3 formulas I'm going to use? It depends what the claim is about. The claim is about the mean. So we can choose the first formula or the second formula. Now, which of these 2 formulas I'm using, the Z formula or the T formula? Well, it all depends on the information, additional information you have in the word problem. So for example, when do I use Z formula? When the sample size is bigger than 30, which is not, or the standard deviation of the population is known. When I read the word problem, I never read assume the standard deviation of the population is nowhere. Okay, so that means I cannot, the formula that I'm going to use cannot be the Z formula. It has to be the T formula. See, look what it says here. When do you use the T formula? When the sample size is less than 30, which is in our case, the sample size is 18, and or the standard deviation of the population is not known. I don't know that. So I'm using this formula. T equal X bar minus mu divided by S over square root of N. I need to plug in the formula. Who's my X bar? That's the sample mean, which was 7.8. Okay, subtract the mean mu, which is 8, that comes from the claim. Divide that by S, which is the standard deviation of the sample, 0.5. And I'm going to divide that by the square root of the sample size, which is 18. Okay, let's use a decimal calculator. I need to change this to an 18. See, I just type in here exactly what I wrote here. And you can see that it's going to be negative 1.697. So if I round to 2 decimal places, negative 1.70. That's how much is this? T. This is what we call the test statistic. Now, why do I need this number? This is the number that I'm going to use to label my marks. Now, remember in the bell-shaped curve, okay, in the middle, we have the mean, and we're counting standard deviations. The mean in the middle is going to be 0. Okay, not that the mean is 0. That's the mean is 0 standard deviation from itself. That's what that means. And this number, I'm going to use it to label my 2 marks. Now, because it's negative 1.70, I'm going to put this one negative 1.70. And then how do I label the other marks? Same number, but positive. Okay, every time you have 2 tails, you have the same number, but with opposite sign. Okay, that's what I need step 4, so I can label these marks. Here we go now with step number 5. And what is step 5? I need to find the p-value. What is the p-value? How much I shaded in the 2 tails. That's what it is. That's my p-value. And how do you find that? Well, you're going to use one of the calculators, or you use this calculator, or you use this calculator. Now, how do I know which calculator I'm going to use? Look at step 4, the formula, how it starts. When it's Z, you're using this calculator. When it's T, you're using this calculator. So I'm going to use this calculator. All right. So the first thing I need is my degrees of freedom. What is the degrees of freedom? The sample size and minus 1. So if my sample size is 18 minus 1, this will be 17. The next thing I need is the t-value. And who's my t-value? That's what we got in step 4. Let me minimize this. Step 4, I got negative 1.70. That's what I'm going to type here, negative 1.70. Hit calculate. And you're going to get 3 answers. Okay, you have 2 answers that are one tail. Okay, if you shaded the right tail, will be this answer. If you shaded only the left tail, that will be this answer. But in my case, I shade both tails, so it will be my last one here. So my p-value, 0.1074. I always round to 4 decimal places. So my p-value is, let me write this out, and I had to call the calculator. I forgot the number. 0.1074. Let me make sure. Yes, and I did step number 5. Now we're going to do step 6. And what is step 6? That's when we make the decision. How do you make the decision? It's based on this chart. Okay, and in this chart, we're comparing the p-value against alpha. Who's my p-value? We just did that in step 5. 0.1074. Who is my alpha? We did that in step 2, 0.05. And now from left to right, 0.1074 is bigger or smaller than 0.05? It's bigger. And according to the chart that I put in the lecture notes, when the p-value is bigger than alpha, what will be our decision? It will be fail to reject HO. That's what I'm going to type here. Fail to reject HO. Okay, that's what it says, the chart. That's how you make the decision. Now we're going to go to the last step, step number 7. That's when we make the interpretation. Let me show you the step. Okay, the interpretation, step 7. How do you make the interpretation? That's when you use this chart. Okay, you need 2 things to make the interpretation. First, what was the decision? Fail to reject HO. So I'm in the second row. Okay, and where is the original claim? The original claim is in HO. So I'm in the second row, first column. So wherever the second row and first column intersect, that's my interpretation. So my interpretation will be there is not enough evidence to reject the claim. That's gonna be my interpretation. Not enough evidence to reject the claim. I just want to make sure I chose it correctly. Yes. Okay, and that's how you test claim. In this case, when it's about the mean and you do not know the standard deviation of the population.